And now we're on to the last one for this first section of finding areas. All right, other things you might have to consider. And again, that final method we'll add after we do some practice the first day. All right, so every time you're trying to calculate the area of a region, you need to break it down to as many parts as possible. You need to know what's on the top and what's on the bottom. And each individual section shouldn't have different things on the top and bottom. So just like we did in the previous video, identify those places where switches happen and change your integral appropriately. All right, so let's say we're trying to find this area here, this area labeled R. All right, you're asking yourself, what's on the top and bottom? Well, for the first part, on the top of this function is this red curve, that's f of x. For the second part, we have the blue curve, which is g of x. And on the bottom, the whole time on the bottom, it doesn't actually change. It's the x-axis. So when we're trying to find this area, the first part is red on top and the x-axis on the bottom. So that's just the integral of f of x, which is x squared dx. They're going to add the second part. The second part, when that switch happens, is when the blue function's on top and just the x-axis on the bottom. So we don't need to subtract anything. We just do the g of x function dx. And now we just have to figure out the bounds. We know it starts at 0, so our very first one is 0. It ends at 2. And then where does the switch happen? In the graph, you can kind of tell it's 1, but just to make sure, x squared equals 2 minus x squared plus x minus 2. All right, so we do confirm that 1 is the place where this switch happens, like that. All right, so basic idea is just know that you have to break down your areas into as many parts as you need to. So this one, really similar to the last video, where we break it down when that switch happens from the red being on top to the blue being on top. All right, in this problem, we're a little bit luckier that they're both on the bottom is the x-axis, so we don't need to subtract anything because our normal integral takes into account the x-axis being the bottom of the area. And so now we can do our antiderivatives. All right, add 1 to the exponent, divide. We're going to evaluate that one from 0 to 1. We're going to add 2 becomes 2x. This becomes minus x squared over 2. And you're going to evaluate that from 0 to 1. Again, we got the antiderivatives now. Now it's just plugging in some numbers. So again, I'll kind of pause the recording, plug in a bunch of numbers so we can see the final answer. All right, so again, I just plugged in all the necessary numbers. I had 1, 0. I made one mistake before I paused the video. I had 0 and 1 for the bounds of the second one, but we know we need a 1 and a 2. All right, so 1 and 2. There, plug all those numbers in. Just simplify a bunch. And you get 5/6 units as the area of this red or that R region there. All right, so again, when we're thinking about areas between curves, what we basically learned is really it's just setting up an integral where you subtract one function from another. All right, the extra work comes in you having to figure out where the switches happen, like in the last 2 videos, or in the first video, we had to figure out where the kind of the endpoints were because those weren't told to us. All right, so you end up having to solve these different equations to figure out where the different bounds are. The basic idea is each time you set up an integral for an area, again, remember this symbol here, the integral symbol means area. Actually, any single time you're finding an area, make sure in that section, there's always just a single function on the top and just a single function of the x-axis on the bottom. And every single time that switches to a different function on top or bottom, you have to create a new separate integral. It's just the basic idea of finding the areas between curves. And like I said, in class, we're just going to do some practice problems, some web-assigned practice on finding these areas. All right, so you kind of have to get used to like making the picture, figuring out what exactly is happening, where the switches happen and all that. We're going to work on it for 2 days, but the first day we're going to do just these 3 methods. And then for the last day, we're going to add in the next method, the final method that'll be covered in the next video.